In this example, we are going to find the volume from rotating the area bounded by the curve y equals x squared, the line x equals 0, and the line y equals 1 rotate about the y-axis. Let's look at this graph. Y equals x squared is a parabola graph. X equals 0 is the y-axis. Y equals 1 is the horizontal line, and the y-axis is the axis of revolution. When we put all three graphs together, we have x equals 0, y equals x squared, and y equals 1. The axis of revolution, y-axis. So the graph rotates about the y-axis. With this method, we make a slice perpendicular to the axis of revolution. That shows us the thickness is delta y or dy. That's a sign of the integration with respect to y. So we have to look for the interval of integration in y. So the lowest y is 0, the highest y is 1. So the function in x has to be rewritten as the function in y. So y equals x squared becomes x equals square root y. Next, the radius. The radius is the height of the bar measured from the axis of revolution. So the height of the bar is from the difference of the right function and the left function. The radius r in terms of y is the right function minus the left function. And the right function is the function x equals square root y. And the left function is x equals 0. Therefore, the radius in terms of y is square root y. Set up the volume. V equals the integral from 0 to 1 pi the radius squared or square root y squared multiplied by the thickness, which is with respect to y. Or we get pi times integral from 0 to 1 of y with respect to y. Find the antiderivative of y, which gives us y squared over 2. Evaluate from 0 to 1. Substitute the upper limit. We have 1 over 2, the lower limit 0. Therefore, we obtain the volume as pi over 2.